Hello, in this video I will be showing you how to solve the Jolly Rancher problem. First, let's read the problem. A Jolly Rancher wants to construct a rectangular corral that is as large as possible. He has 1,000 meters of fencing available for the sides. What is the largest area he can enclose? There are two values we have to consider in this problem. One is the area and one is the amount of fencing available. We can represent these values by writing two equations. The first will be the amount of fencing, with L being the length of the corral and W being the width. So we would write 2L plus 2W is less than or equal to 1,000, for L and W being greater than 0. Because we want the enclosure to use less than 1,000 meters of fencing and a rectangle has 4 sides of which the opposite sides are congruent. The second equation would be for the area, which we want to be the greatest possible. We would write this as L times W equals area. Because we know the area of a rectangle can be found by multiplying its length and its width. Now we have to find the optimal length and width for the corral. We can do this by creating a graph, but we have 3 variables and can not graph it on a 2-dimensional graph. To fix this, we can solve for either L or W. In this case, I will solve for L. We can subtract L from the first equation and divide everything by 2. This yields us L is less than or equal to 500 minus W. We can simplify this further into L equals 500 minus W because we want to use the most fencing to get the largest area. Now we can substitute L into the second equation, giving us the quantity 500 minus W times W equals area. And if we simplify this, we get 500W minus W squared equals area. This is something we can graph. If we do so, we can get a parabolic shape with area being the y-axis and width being the x-axis. We can now get our answer by seeing which point on the line has the greatest y-coordinate. 250, 62,500. With this, we can see that the greatest area would be 62,500 square meters.